Hello everyone, welcome to this session. Our chapter is waves, and we're still discussing about the behavior of the waves. As for in our previous video, we discussed there about the interference. So today let's move on to the other behavior of the waves, whereby we'll be discussing the diffraction. So we'll start with the concept of diffraction. This diffraction is the other behavior of the waves. Uh, Diffraction, it refers to the change in direction of the waves as they pass through an opening or just around a barrier in their path. So this is the other behavior of the waves, whereby it illustrates how waves they change in direction when they pass through an opening, or it can either also be around a barrier in their path. So that's what we call a diffraction. And here is how it looks like. For example, we can see how it is illustrated as the wave goes through the gap and it spreads out. So this is what happens. So this is the wave that was traveling here and it encountered a barrier. Now after encountering this barrier, it changes its direction. So that's what we call the diffraction. The same thing happens if it goes around an obstacle. So here it has encountered maybe this obstacle that is blocking it. Now it has passed, so it has passed through this gap, while in here there's this obstacle that it has caused this wave to change its positioning or just its normal flow. So that's the concept of the diffraction. uh, the diffraction phenomena is described as the interference of waves according to Huygens Fresnel's principle. So this diffraction phenomena, it can be explained by this principle. Now, these characteristic behaviors are exhibited when a wave it encounters an obstacle or a slit that is comparable in size to its wavelength. So that's how this behavior it can be seen. Similar effects they occur when maybe a light wave travels through a medium with the varying refractive index, or when a sound wave travels through a medium with the varying acoustic impedance. So this is how it occurs in these kinds of different waves. Here we're talking about the light waves and the sound waves. Uh, Diffraction occurs with all waves. You can see it in all kinds of waves, including sound waves, water waves, and electromagnetic waves, such as visible light, X-rays, and the radio waves. Now, diffraction arises because of the way in which waves they propagate. This is described by this principle we said, Huygens Fresnel principle, and the principle of the superposition of the waves. So it can be described by these two. The propagation of wave can be visualized by considering every particle of the transmitted medium on the wavefront as a point source for a secondary spherical wave. So the propagation or the movement or the flow of the wave, it can be visualized or seen by considering just every particle of the transmitted medium on the wave front as a point source for a secondary spherical wave. So that's what it is. The wave displacement at any subsequent point is the sum of these secondary waves. So the wave displacement, you are talking about that kind of displacement of these waves at any subsequent point that can be observed is the sum of all these secondary waves which we see after encountering a barrier or an obstacle. These waves are just put together. Their sum is just determined by the relative phases as well as the amplitudes of the individual waves, so that the sum, the amplitude of the waves can have any value between 0 and the sum of the individual amplitudes. So all the waves, these are talking about the secondary waves, they are put together. The sum is just determined by just their relative phases as well as the amplitudes. We talked this concept. Its meaning actually when we are discussing all the terminologies related to the waves. So amplitude is just the length of the wave of these individual waves, just so that the summed amplitude of the waves it can have just the value between 0 and the sum of the individual amplitudes. So that's how it is. A strong set of infinitesimal width which is illuminated by the light diffracts the light into a series of circular waves, and the wavefront which emerges from the slit is a cylindrical wave of uniform intensity. So the long slit of this, which is illuminated by light, it just diffracts the light into series of these circular waves. So this diffraction of this light into this series of circular waves in the wavefront, which emerges from the slit, just a cylindrical wave of the uniform intensity. A slit which is wider than a wavelength produces the interference effects in the space downstream of the given wave. Now, this can be explained by assuming that the slit behaves as though it has a large number of point sources spaced evenly across the width of the slit. So, and here is how you can see we're still discussing how it works. So from here, now slit broad splitting, as you can see, the wave traveling and encountered this, and how it appears then. And the broad slit narrow splitting. So a narrow splitting will cause so this is just the diagram or presentation of what we've seen those explanations. So slit is like a barrier, so a narrow slit leads to broad splitting of the wave after encountering the slit, and the broad slit, yes, it now leads to narrow splitting. So that's how it is in terms of how diffraction it occurs. So that's all I have for this session. It has been briefly about the meaning of the diffraction. This is the other behavior of the waves. So we've discussed the concept of the diffraction, how it occurs, and its actual meaning, like what is diffraction. So hope that's clear, and thank you.